Hi everyone, welcome to my channel. We are asked to decide which of these graphs here will represent the curve of the function y equals to 2 to the power x. Y equals to 2 to the power x is an index expression. Here the base is positive, and there is no index expression with a positive base that will give us a value 0. Okay? No matter the value of the power and no matter the sign, this expression will always give us a value that is not 0. Here, the value will actually be greater than 0 because the base is positive. For example, if we have a negative power, if the value of x is seen as negative, for example, -1, from the laws of indices, it is a half, and this is clearly greater than 0. If the value of x is -3, for example, this means 1 all over 2 to the power 3, which is 1 all over 8, and this is greater than 0. In fact, there is no value of x that will render this expression 0. And so we don't expect y to be equal to 0 for any value of x. Now, if we look at the graphs, let's start with this first two. Look at these graphs. We see that they come and cross the x-axis. And along the x-axis, the value of y is 0. If this graph crosses the x-axis, it means y can take value 0 because along the x-axis, y is 0. But we have just seen here from this our analysis that y can never be 0. It therefore means that this option here, any option where the graph crosses the x-axis, should be rejected. These two options are rejected because the graph comes and crosses the x-axis. Now, what about this other two option? The graph does not cross the x-axis, all right? But we see that the graph crosses the y-axis at a particular value 1. When y is 1, the graph crosses. Now, let us check if that is true, all right? Remember, along the y-axis, x has the value 0, all right? Along the y-axis, x has the value 0. So let us put 0 there and see. 2 to the power 0. All right. Any number raised to the power 0 is 1. So when x is 0 along the y-axis, we expect y to be 1. So that aspect is correct for the both graphs. It is correct. All right. We expect the graph to cross the y-axis at the point 1 because along the x-axis y is 0. Sorry, along the y-axis x is 0. Now, we'll look at the next aspect now. Which one now is going to be the right graph, this or this? We see that this graph here slopes like that or curves like that, and this other one curves like this. All right. Simple analysis can be done. If we look at this one, it shows that when the values of x are increasing, the corresponding values of y are also increasing. This is y1, this is y2, this is y3. All right. Y1, y2, y3. All right. So when x is increasing, y is also increasing. Now let us check here. If we check on simple values, let's take simple values 1, 2, 3. When x is 1, we have y is equal to 2 to the power 1, which is 2. When x is 2, we have 2 to the power 2, which is 4. There's an increase. When x is 3, we have 2 to the power 3, which is 8. There is an increase. So the behavior of this curve responds correctly or in exactly the same way as a simple evaluation of the expression. So this curve tells us that it can actually represent this expression. Now, let's check the same thing here. Let's just take random values again of x in increasing order. Random values of x in increasing order. Their corresponding values of y. Okay, the corresponding values of y. You see that when x is increasing here, the values of y are instead reducing. This is x1. It gives us this value. And x2 should correspond to y2. See, y2 is instead smaller than y1. And of course, y3 down here, it will come somewhere here, far even smaller. So here, this graph is telling us that when the values of x are increasing, the values of y are instead decreasing. And that is not true from a simple analysis that we just saw a while ago. So this option is out. So the only option that can represent the curve of this exponential expression is this one.